Hello everyone, I am Safia Parveen from CA department. Today I want to discuss a topic on Kruskal's algorithm to find minimum cost spanning tree. Kruskal's algorithm follows a greedy approach. In this algorithm, we are using a non-linear data structure called graph. A graph is nothing but a collection of several vertices or nodes and edges. Each edge is connected to any two vertices in a graph. Each edge has a weight. Weight is nothing but a cost or distance between two nodes or vertices. Normally, a graph is denoted by G of V, E. A spanning tree is a tree which is a subgraph of the actual graph which connects all the vertices of the graph. A minimum spanning tree is a tree in which we are finding the sum of all weights of edges which is minimum. Some properties of minimum spanning tree are: a graph can have more than one spanning tree, all the possible spanning trees have all the nodes and vertices in the graph, and it should not have any loops or closed paths or circuits. It should not have any parallel edges. Now we will consider the minimum spanning tree where we are applying. So normally we are finding the minimum spanning tree in finding the minimum cost for the network related problems. Where we are using is in civil network planning, computer network routing protocol and cluster analysis. So now let us go to the Kruskal's algorithm, the procedure. So first what we have to do is we are taking a weighted undirected graph in which we are having all the edges. So first we have to sort according to the edges in the increasing order of their weight. Now go to the second step. So we have to pick the smallest weight edge. Now we have to form a minimum spanning tree. So first let us take the smallest weight edge, and then if we are adding this edge, if it is forming a cycle, we have to check. Cycle is nothing but a closed path. If it is not formed, we can take the edge to the minimum spanning tree, else we have to discard that edge. This is the procedure. The procedure step 2 is repeated again and again till all the vertices have been connected or V minus 1 edges reached in the spanning tree. V is nothing but all the vertices in the graph. Now let us explain with an example. We are taking a graph, we are taking a undirected weighted graph with 6 vertices. So we are representing A, B, C, D, E and F. All our vertices represent cities, and we have an edge, edge which connects any two vertices called edges, and every edge has weight. For example, AB with weight 3, BC with 5 weight, CD with weight 4, ED with weight 2, AE with 4, EF with 5, AF with 7, CF with 6, FD with 8 and BF with 8. So now the procedure is we have to sort out the edges according to their weights. So in this undirected graph, we are taking the smallest weight edge, ED. ED with weight is 2. So we are taking the edge. First we are taking ED with weight 2. Then we are taking the next shortest edges, AB with 3. Then we have AE with 4. Also CD with 4, and then BC with 5. Then we have EF with 5, CF with 6, AF with 7, BF with 8, CF with 8. So according to the weight of the edges, we are sorting the edges. Based on that, we have to list out the edges. So that is the first step we finished. Next, what is the next step we have to do is, from the out of these edges, we are taking the shortest path edge. So here, out of all the edges, ED with 2 is the shortest edge. So we are taking ED with 2. While we are adding E2, any cycle is formed? No. So we are taking that edge. So next we have to select the next shortest edge with does not create a cycle. So the next shortest edge is AB with 3. So we are taking that edge. So that also not form a cycle. So next we have to select the next shortest edge. So with weight is 4. So we are taking either CD with 4 or AE with 4. Both are same weight, we are taking both. So they do not form a cycle. So we are considering both the edges. Next we are taking the next weight edge. So we are having edge with EF with 5 as well as BC with 5. But if you are taking BC with 5, it form a cycle or closed path. So we can't take the edge BC. So next what we have to do is EF, the edge EF with 5 edges taken. Now we have to check whether all the vertices have been connected. So here in this case we are connecting all the vertices or nodes. So here the solution is ED with 2, AB with 3, CD with 4, AE with 4 and EF with 4. So we have to find the total weight of the minimum spanning tree. So here the total weight is 2 plus 3 plus 4 plus 4 plus 5. So the total weight is 18. So this is the minimum spanning tree for finding the Kruskal's algorithm. So in this way we have another 2 algorithms are there for finding the minimum spanning tree. So the other algorithm names are Prim's algorithm and Solin's algorithm. Prim's algorithm procedure is similar to this Kruskal's algorithm. The only difference is we have to arbitrarily choose a node and then we have to follow the procedure as in Kruskal's algorithm and we have to find the minimum path. So Solin's algorithm is similar to these 2 algorithms. In this way we are finding the minimum cost spanning tree. So these are the 3 algorithms we are used in finding the minimum spanning tree. Out of these 3, Kruskal's algorithm is the familiarly used algorithm. Okay, thank you.